Let's study the topic of stopping distance for a vehicle. What this stopping distance means, suppose this is a vehicle. Let it be, this is a vehicle. Okay, this is a vehicle moving on a road, and this is moving with some acceleration. Okay, some acceleration, and this we suddenly applied brakes. Okay, we suddenly applied brakes, and just we applied brakes, it will not stop there. It will travel some distance and then it will stop. Okay, after applying brake, it will cover some distance, and this distance is called a stopping distance. Okay, so we can write it here. We can write in the definition, the distance traveled, a stopping distance is the distance traveled by a vehicle to a stop completely after applying brakes. Okay, this is the distance traveled after the brakes are applied. Okay, distance traveled after the brake. Suppose we are cycling and we applied the brake and the cycle stopped after some distance. Okay, so this distance after the brakes are applied, distance after brake, you must remember this is the distance after applying brake. Okay, what distance does the vehicle travels after the brakes are applied, okay, to a stop? This is one important factor of road safety. You know, it's an important factor of road safety, because if the vehicles will stop after very much longer distance, it may be collision of accidents. Okay, now let us calculate how to calculate the stopping distance is what? Let it be SD, stopping distance. Let SD be a stopping distance. Okay, we assumed let SD be the stopping distance. Now here we see one equation. We remember the vehicle is traveling with some acceleration A. Okay, and we have to find stopping distance. This equals to what? Okay, and so one equation we remember, V square equals to U square plus 2as. Okay, here it is. Final velocity is what? A stopping distance is what? Final velocity must be 0, because the vehicle has stopped finally. So final velocity is 0 here. So v square will be 0. Okay, and initially it may have some value. Okay, plus 2a. In the place of s we put sd, stopping distance. Okay, then it is sd equals to what? Sd will be minus u square by 2a. On solving, on solution, it will come to this minus u square by 2a. It means what? This is a formula for a stopping distance, minus u square by 2a, and this formula means stopping distance is directly proportional to initial velocity. Let us see one question related to stopping distance. Here, a car is moving with a speed of 50 km per hour, can be stopped by brakes after covering 6 meters. Okay, what will be the minimum stopping distance if the same car is moving at 100 km per hour? There are two cases in the question. In the first case, a speed is given this, and the brakes are applied, the car covered 6 meters. Okay, so let's elaborate the cases. Solution. First case, it is initial velocity is 50 km per hour, it is given. Let's convert it. 50 into 15 by 8, 5 by 18, sorry, 5 by 18 to meter per second. This is 9, this is 25, so it is 125 by 9, this much meter per second. Okay, and what is can be stopped by brakes after covering 6 cm, it means 6 meters. Okay, it means distance traveled here is 6 meters given. Okay, and stopped means final velocity is 0. Okay, this all is given. Now what we have, what we require? We require what will be the minimum stopping distance if the same car is moving at 100 km per hour. In the formula of a stopping distance we know SD equals to minus u square by 2a. Here we have initial speed, that is 100 given, and we don't have this acceleration. Okay, we don't have this acceleration, so we will try to find this acceleration, and we can get it from first case. We will get acceleration from first case and we will put simply in this formula. Okay, then we use the relation v square minus u square equals to 2as. That is why we used this, because final velocity is given, initial velocity given, s is given, and a is not given. This we have to find. Okay, so final velocity is 0, 0 minus u square, that is 125 by 9, this much square equals to 2a. So acceleration will be 125 into 125 by 9 into 9 by 2, this much, and 2as is 6 lacking here, so it is, this will put 6 here. Let's calculate it. Then after calculation it will come approximately to 16. Okay, this is minus 16. Okay, a equals to minus 16. Why it is minus? Because it is working against the motion. Okay, this acceleration is working against the motion. Okay, this is working to stop the car. Okay, the car is moving in this direction and this acceleration is working in this direction, opposite that motion. So the sign is minus here. Okay, now the stopping distance is minus u square by 2a. We know that. Now here in second case, initial velocity is what? U is 100 given, u is 100 km per hour, and this 100 into 5 by 18, 9 to 18, 50, this is 250 by 9, this meter per second. It will come like this, and so we will put here minus 250 by 9 square by 2 into minus 16. That is this cut, minus signs cancelled, and then on calculation it will come to 24.1 meters. Okay, this is the answer. So in the first case acceleration was lacking, we found the acceleration from the first case and we put it in the formula here in the second case. Okay, thank you.